is 1 comma 5.
Yeah.
Then you do the same thing for 2, which maybe that's where it gets a little bit worse. Not too bad. 10 over 2 squared plus 1. That's 10 over 5, which is 2. So your second ordered pair is 0, comma 2. Okay. To define the equation of the secant line, you have to determine the slope between these 2 points. Okay.
Right.
So the slope is 2 minus 5 over 2 minus 1, which is minus 3. So it could be that it is this one right here, but then you got the whole like, well, there's none of these, so you better find the b values. So probably good to write y equals mx plus b, y equals minus 3x plus b, and use one of the ordered pairs. And I'll just use the first one there. So 5 equals negative 3 times 1 plus b. B ends up equaling 8, and that confirms
Okay, so I
the
did that one
answer there.
correctly. Okay, perfect. I'm trying to figure out because I got an 86, but then he
Okay.
like looked at my work and then changed my grade to a 96. So I'm trying to decipher which problem I did wrong. I'm not sure which one I did wrong. There's one, I think it's question 2, but like the light is like on it. It's consider the function f of y equals 1 over the square root of t squared minus 1.
Let's take a look at that. So the key to this problem is being able to take a derivative. So it's 1, like you're looking at this is 1 over the square root of t squared minus 1. So for example, you could rewrite this as t squared minus 1 to the minus 1/2 power.
Yeah, that's what I
Okay,
did.
and that's probably what I would do. And then now in terms of your derivative, it's a chain rule derivative. So you're using power rule first, your power rule of minus 1/2, keep the inside function minus 3/2, and then you take the derivative of the inside function, which is 2t.
Yeah, that's what I did. Okay.
Okay, so now in terms of like, a little manipulation here, you rewrite this, the 1/2 goes with the 2t's to make just t. So it's t negative over, and usually you move this to the bottom, t squared minus 1 to the 3/2 power, something like that. And then the slope is just putting this number minus 2 in for t and in for t.
Right.
Okay, so it becomes minus 2 over minus 2 squared minus 1 to the 3/2 power. So this ends up being 2 over minus 2 squared is 4, minus 1 is 3, 3 to the 3/2 power, which is not showing up here. So it's the yeah, square root of 3 cubed is 27. So I'm not seeing it. I think there's a problem with the answers. So let me use another tool here to be able to confirm that.
See, because I got that exact answer and I didn't know where, like,
Yeah. 1 over square root x equals minus 2. Now there's a little bit of an awkwardness because it's f of y and it's the t squared. It's almost like the instructor changed the problem. Yeah, none of these are correct. I mean, I don't know if this was the none of the others, but yeah, none of them are correct. So
okay, yeah, because that was my answer as well.
okay. Well, seems to me that you may want to ask your instructor about this one.
Yeah, I think that's why he gave like so many points back, like because he literally gave 10. So I'm
Oh,
thinking
nice.
that was
Nice.
what
Nice.
the issue was.
Okay,
Okay, so I did that correctly.
great.
Can we do number 5?
Sure. So this time I'm not going to step in the answers quite yet. I'm going to just grab the problem. All right, the normal line to a curve is perpendicular to the tangent line. So it's kind of like basically it's saying like find the tangent and then take the normal to it, which is opposite reciprocal. So this is an implicit derivative. So derivative of x is 1, the derivative of y is 2y dy dx. And if we solve for dy dx, we divide both sides by 2y. dy dx equals 1 over 2y. All right, so this is where you would put in the y value. So you end up getting 1 over 2 times 1/2, which is 1. And so your slope, your tangent slope, and this is important, your tangent slope is 1. The normal slope is the opposite reciprocal, so it ends up being -1. You can write that here, opposite reciprocal or flip negate, like that. So you start looking at the answers and you're saying, okay, well, which of these have a slope of -1? But because it says none of the others, we probably need to find the whole thing. So let's write it this way: y equals -1x plus b. We'll use that point. 1/2 equals -1 times 1/4 plus b. 1/2 equals -1/4 plus b. Add 1/4, add 1/4. B equals 3/2. No, sorry, that's not right. 3/4, sorry. So that goes back in here. So we have y equals -1x plus 3/4. Multiply everything by 4 with standard forms. This ends up being 4y equals -4x plus 3. And then you move that one back over. So you get 4y plus 4x equals 3. And that's where we're at the moment.
Okay, yeah, I think I did that one wrong. So, okay, that makes more sense.
Okay. The other thing to do here, I mean, I couldn't, is you could actually graph this and then graph all the lines and see if any of them look normal to it. Again, the idea is like, if this is the tangent, the normal is going to be 90 degrees to it. So tangent and then the normal to that.
Okay. Okay. Can we do 11?
Sure. So consider the piecewise function. Here we go. All right. Find the constants A and B such the function be continuous over its domain. All right. So the short of this is that you gotta evaluate each of the pieces at the endpoint. So you gotta take 2 times 2 squared, that's the 2x squared, equals A times 2 plus B. Okay. So like it's like you're looking at these two equations right here at x equals 2. We've done that here. That's 4. I'm sorry, that's 8 equals 2a plus b. And then you do the same thing for these next two. And you again, you evaluate at the endpoint a times 5 this time. So at x equals 5, the other kind of edge point, endpoint, in between point, 2 times 5 plus y equals 15. That's bothersome. Why is there a y value in there? That's really weird. That shouldn't be there. Okay, well, we'll just keep going here. Yeah, that's really not right. There's a problem here. Like, this is not right at all. I don't know what this is just. We could probably guess it like with like, I could check some of these A values. Maybe the instructor meant B, then, but we're missing, yeah, I mean, this is just completely wrong. So you'll have to, I'm sorry, you'll just have to ask your instructor.
That's okay.
Um,
We can go to number 13 then. That one kind of threw me for a loop.
Sure.
It's not similar to any of the other problems, so.
Find P prime of 0. Oh, boy. So this is another one where the instructors probably made a mistake in how they presented it. This happens when you're copying things over. So P prime of 0. Well, wait a second. No, I take that back. Maybe we can find this. So the derivative here, this right here, this is what we should be focused on. This R of X equals S of T of X, like that. So the derivative R prime of X is S prime of T of X, keep the inside function, times T prime of X. So if we're interested in R prime of 0, that means it's S prime of T of 0 times T prime of 0. So actually, we may be able to do this. We're solving for this little piece here. Now that I look at the end, it's actually a pretty good question. So you would divide both sides by this. This S prime of P of 0. And so T prime of 0 equals R prime of 0 over S prime of T of 0, like that.
Okay.
And now, do we have R prime of 0? We do. It's 2. And then T of 0, do we have T of 0? Yes, T of 0 is 0. And so S prime of 0 is -3, and that would be our answer, which actually is there in the solution space.
Okay. Sorry, I'm like going back and forth to see what I did versus where.
Yeah.
Um, yeah, I put it as, yeah, okay. I see where I messed up. Okay, cool. Perfect. Can we start the homework problems now? I think it
Sure.
starts at number 7.
Okay. The value of the derivative, relative extrema, find the value of the derivative exists at each indicated extremum. Okay. So the graph really isn't necessary.
Okay.
It's nice that they give it to you, but you have to be able to take a derivative of this. Okay. So if you're not sure how to take a derivative, that's really bad. It's
Right.
the expectation is that right now in this course, you can take a derivative of everything. Like there's never any questions about how to take a derivative. Okay.
Okay.
And this is where if I take the derivative, it's slow. So what I generally do at this point in the course for most students, unless they really, feel unprepared, is I just use something to take the derivative. So I'll do that here. And if you have questions, we can do it. So then you set the derivative equal to 0. And this is where all your pre-calculus, college algebra, your previous class, this is where that comes into play, because you're supposed to know, and when I say that, I just mean that's the expectation. You're supposed to know now that, well, the numerator has to be 0. You don't actually care about the denominator, it's the numerator equal to 0. So set the numerator equal to 0. So you set 8x equal to 0, and you find that x equals 0.
Okay.
And so that is an extremum. And that's what they're looking for. Now the second piece, and the graph is helpful. The second piece is you go back and you evaluate at that place. Like that.
Okay. Yeah.
And that's it.
So we're just proving that it's like extreme.
Well, the critical, I mean, we have the graph, so there is more here, but it's not alluding to it. So there's the first derivative test. And then there's the second derivative test.
Right.
And I mean, it doesn't say, you'll have to consult your notes, I guess, to tell me. I think because the picture is there, they're trying to get you to see, okay, it's right there, just show that it's right there.
Yeah. Okay. Perfect. Okay, and then can we do number 9?
Sure. It's kind of the same deal here. We have to take a derivative. It's really the quotient ones that are kind of the pain to do. So the derivative of this, because you can rewrite this as x plus 4x to the minus 2, is 1 minus 8 over x cubed. And then you set, so that's the derivative. You set this equal to 0. So you have to solve for x. Now you want to be careful. I mean, it's nice when they give you the graph because you say, oh, it's x equals 2, but you really want to get into the habit of working it out, like this, and then multiplying both sides. So x cubed equals 8. So x equals 2, or x equals 2. So there you go. And then you put that number back in, you go back to the original, and you say, okay, g of 2, it's 2 plus 4 over 2 squared, 2 plus 4 over 4, which is 1, which is 3.
Okay. Mm. Can we do number 13?
Sure. Approximating critical numbers in these exercises, approximate the critical numbers determine the functions of relative max, relative min, and absolute max, absolute min. Okay. So the graph here. So there's like a bunch of cases. Is 13 the one? Yeah, that's the top graph. Okay. There's a bunch of cases here that you're not getting. Like this is only one. Like this is kind of an exception. Like normally, okay, so see how I'm not being clear. See how these are open circles down here?
Yeah.
So even though it looks like there's a min there, it's not because it doesn't exist. So you can only have a min or a max at a closed point. Okay, so there actually is a max up here. That's okay because there's actually a point up there, but there's no min, even though you're like, but look, it's right there. It's like, nope, it's not there. It's not defined. Okay, so they like this has a max, but it does not have a min. And now, so now you ask yourself, well, is it the absolute max? And it is. It's the absolute max because it is the highest point. So I don't know if you hike much, but it's kind of like you could get to a place where you think is the max, but then it goes up a little bit higher, right? So this is a relative max. And that's why I say we're not getting all the cases. This is an absolute max. Okay. And you could get a min like this. That's a min, a relative min, but it might be that this goes down even further, and that's the absolute min.
Okay.
So there's all these things you're not getting in these problems that you need to be aware of.
So is that similar to then like problem 16? Where it's
Let's
like
take a
it
look.
has 2 maximums and then like,
Yeah, exactly. It's got, well, so unfortunately, because this is yet another kind of exception. The first one, I'll snip this in. The first one is a horizontal tangent.
okay,
So there's nothing there. Like a horizontal tangent is nothing. It's neither a max nor a min.
okay. And is that just because it's like kind of straightens out?
Yeah.
Okay,
So it has to actually be a max or a min to,
no, okay, so if it like bumped up a little bit higher and then went deeper into like a valley, then we would have.
Yeah.
Okay, so kind of like number 15, then like the one right above it, where it's just like. Yeah, and how does number 15 work? Because they're very like, aren't they like even with each other?
yeah. So this, yet another kind of example. So there we go. We got this in front here. So this point right here is defined right there. That is the min.
Yeah.
And it's the absolute min. It's both a relative min and an absolute min. Okay. Both of these places are maxes. They're both relative maxes, like they're relative to the around them, they're maxes, but they're also absolute maxes
Okay.
because they're both the highest point.
Yeah. So then when it has like 2 points like that, it'll be a relative max. It won't be an absolute max.
No, they're both absolute
Oh,
maxes.
oh, okay.
Yeah.
Oh, so they're
What I'm saying
both.
is that is they can be both. They can be both a relative and an absolute max.
Oh, okay. Okay. We do number 17.
Sure. Yeah, so this is more what you'll see on a test or quiz.
Yeah.
So when it says find the critical numbers, so why don't you take the derivative of this and see if you can set it equal to 0?
So set it to 0.
Yeah, if you could take the derivative and set it equal to 0, be good.
Oh, yeah. Yeah. AX minus 6 equals 0.
Yeah, so what does that end up being?
6/8.
Or 3/4, x equals 3/4.
Oh, yeah.
So now, that's all it's asking for, I believe. The reason a critical number is just wherever it equals 0. Right? Like there's no that's it. Like you don't have to prove that it's a min or a max. Is that okay? I mean, I don't know if
Yeah, let me see what they had as their like answer to see if it was just similar. Yeah, no, that's all they had. X equals 3/4.
that's it. I mean, there's no,
Yeah. Okay.
so critical numbers, critical points just means setting the derivative equal to 0.
Okay. Perfect. Seems easy enough. Hmm. We do 21.
Sure. So, why don't you take the derivative of this? Let me know what you come up with.
Okay. Two cosine x minus sine x.
So it's 2 sine x, and then you have to take the derivative of sine, which is cosine. And then the derivative of cosine is minus sine x.
Oh, so we still have to, when we bring it down, we still have to keep the sign in there for the first part.
Yeah.
So, okay. Okay.
Okay. So the next thing here is to factor out a sine x, or whatever is the consistent, whatever is the same. So 2 cosine x minus 1 equals 0.
Okay.
Okay, so then you said each of these equal to 0. Sine x equal to 0, 2 cosine x minus 1 equal to 0, cosine x equals 1/2. And you got to solve each of these. So this is where your trig comes in. This is where if you have a reference sheet on a unit circle, maybe you're like, okay, where does it's from 0 to 2 pi. So where is that? So really quick review on your unit circle here. Where does sine, which is the y value, equal 0? It equals 0 at 0 and at pi. And so these are like things you have to know from your previous
Yeah.
courses.
Yeah.
Okay. Where does cosine x equal 1/2? So that's where's the x value 1/2? So it's there and it's there. It's at pi over 3, and then it's at 5 pi over 3. All
Okay.
right. And so again, you're supposed to know that, whatever you want to take that to mean, but it's got to fit from 0 to 2 pi. So here, right here, 0 comma pi, pi over 3, 5 pi over 3, is is your answers are pi over 3, 5 pi over 3 are your 3 answers. 0 is excluded because it's not in the interval.
Yeah. Yeah, they have the same one. Yeah. Okay. Yeah, I just keep the circle, like the unit circle, as my reference sheet because we're allowed notes.
Good,
So
good. No need to remember stuff that
yeah, no, we had to memorize it for my last class, and that was just a pain.
right.
Okay, can we do 25?
25. Okay, this is a good question. This is a good test type question, although I don't know if it's difficult enough, but it's good to do here. So the finding extreme on a closed interval, there's a recipe to doing this, and the recipe is you first evaluate the endpoints. Okay, so you actually find h of -3 and then h of 1. So could you calculate both of those for us, please?
Yeah. H sub -3 is -13.
Okay,
And H1 is just 3.
okay. So now the next thing is you have to take a derivative. Okay, so go ahead and take a derivative of this for me, please.
Mm. 4x.
Minus 4x.
Yeah, sorry. Yeah,
You
minus
set
4.
that equal to 0, and you end up getting that x equals 0. Okay. Hang on just a second, please.
Okay.
All right, I'm back.
Okay.
So it's at 0, but the thing is you have to make sure that that's in the interval. So you set the derivative equal to 0, but is it in the interval? So occasionally you get problems where this is what you're going to see on your test is that it's, is it in the interval or not? And so h of 0 equals 5. And now you just look at these three. And you say, okay, which is the biggest, which is the smallest? So this is the absolute min, and this is the absolute max.
Oh, okay.
And that's it.
Okay. Yeah, that makes sense. We do 29.
Sure. It's the same thing as the previous one here. You're going to have to evaluate it at the two endpoints. So you've got to do y of -1 and then y of 1. These do work out nicely. So just gotta work that out here for me, please.
Yep. So when it's when it has that exponent like 3/2 and it's like with a 1, does it just stay as a like -1, or would we have to like write it all out?
Well, what I would do if I were a student is I would go to my calculator. If I
Okay.
had one. I wouldn't try to remember everything.
Okay.
And if you run into issues, you can do that. But um,
Yeah, see, my calculator says non-real calculation.
right, and so that's where I mean, that may be why they chose these, because you got to pick numbers that actually work here. So let's see here. So what this means is you're taking the cube root of -1 squared. The cube root of -1 squared is still 1. So this ends up being 3 plus 2, which is 5. This one ends up being 3 minus 2, which is 1. So this -1 to the 2/3 power, it means the cube root of -1 squared, which is
Right.
the cube root of 1, which is 1.
Okay, that's what I thought. I just wasn't sure.
Okay. Next is to take a derivative. So could you kindly take a derivative of this for me, please?
Yeah. Two over the cube root of x minus 2.
Y prime. A lot of ways to write. I'll go this way just for, it's exactly what you said there.
Okay.
Okay. So the next thing is to set this equal to 0, and that's where maybe it's better to have it in the format you had it in, which is 2 over the cube root of x equals 2, just moving that 2 to the other side. Cross multiplying here, excuse me, 2 equals 2 cube root of x, divide by 2. So you got this 1 equals the cube root of x equals 1. And that is in the interval, but it's already an endpoint. So you just look at these two. You say, okay, well, that's the max. And that's the min.
Okay. I'm trying to see if I have any more problems for this chapter. Yeah, I think I'm all good. I don't have any more questions for today.
Great, great. Well, we'll just stop a little early. And resume tomorrow. So just to be clear, I think we're doing 11 tomorrow. So just
Yep.
and then but you think 4 on Wednesday and 11 on Thursday. So
Perfect.
all right, thank you so much. I will send you those through shortly, and I'll see you next time.
Thank you.
Bye.